Hey everyone, welcome back to the channel Code with AKJ. Today is day 4 of solving LeetCode 75 challenge, and today's question is can place flowers. So the question says you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, return true if n new flowers can be planted in the flower bed without violating the non-adjacent flower rule, and false otherwise. So if you are new here, please don't forget to hit the subscribe button for daily coding problem solutions. So here we are given a flower bed represented by an array zeros and ones. A 1 means a plot is occupied and 0 means it is empty. And we need to plant n flowers such that no two flowers are adjacent to each other, and our task is to return true if we can plant all the flowers while following the no adjacency rule, otherwise return false. So let's understand this question by analyzing these two examples. So the first example here is the 10001. So the flower bed contains values 1, 0, 0, 0 and 1, and we need to place one flower. We need to place this flower on this flower bed in such a way that the left value and the right value should be empty. So let's try to place this. Can we place this flower at this particular spot? So before placing the flower on this spot, we need to check whether its left and right value is empty or not. So since we can see that the left spot is already being filled with the flower, so we cannot place this flower at this spot. So let's try to move on to the next index. So can we place this particular flower at index 2? So before placing it, we need to check whether the left spot and the right spot are empty or not. So since we can see that the first index and the third index are empty, so we can place this particular flower at index 2. So we remove 0 and we place 1 here. So since our n value is 0, we'll stop the iteration, and in this way we have placed our flower on this flower bed, and we can return true as an answer as we can place all the flowers on this flower bed. So let's move on to the next example. So the next example values contains the same, but here we need to place two flowers. So again let's take the same example 10001, and now we need to place two flowers. So again let's try to write our index values. So can we place a flower on this spot? No, as the left spot is already being filled, and we need to follow the no adjacency rule, so we cannot place at index 1. So can we place a flower at index 2? Yes, as the left spot and right spot are empty, so we can place a flower on this position. So we can remove 0 and place 1 here. We'll reduce 1 from the n value, so n becomes 1 now. So again move on to the next index. Can we place a flower at this particular spot? As you can see, its left and right spots are already being filled, so we cannot place a flower in this spot. And moving on to the next index, there are no empty places left, and we are out of the size of the flower bed, and our n value is still greater than 0. So in this case, we return false as we cannot place all the flowers on this flower bed. So in the brute force approach, we will iterate through the entire flower bed array, and for each plot we check if it's empty or not, and if it is empty, whether the adjacent plots are empty or not. So if we find a suitable spot, we plant that particular flower on that spot by setting the 0 to 1. So we repeat this process until either all flowers are placed or we run out of spots. So the time complexity of this approach would be O of n, as we are iterating over the flower bed of size n, and space complexity would be O of n, as we are not using any external data structure. So let's move on to the code. So let's take the size of the flower bed and store it in the variable size. Now let's iterate over this flower bed, and we'll check whether that particular current spot is empty or not. So if it is empty, we'll check its left spots and right spots, and we'll store it in variable left empty or right empty. if a spot is present at the initial index or at a particular index I, so the left spot may be at the first index I is equals to 0, or can be the previous index which is I minus 1. So we need to make sure that these two cases are being handled. So this covers our left spot check, and same goes with right spot checks. Or the next index could be the end index which is size minus 1, or the next index I plus 1. So these two should be empty. So in this way we'll check whether the left spot and the right spot are empty or not. So if both are empty, then we plant our flower on this particular spot by replacing 0 with 1 and reducing our n value. So after reducing, if our n value becomes 0, we can return true, or else after iterating over the whole flower bed, if our n value is less than or equal to 0, we can return true, or else we can return false. So let's run this code. It's working, so let's submit. As you can see, it got accepted. So here's the breakdown of this code. So we iterated over each plot. So for each empty plot, which is flower bed of I is equals to 0, we check if both its left and right neighbors are empty. So if both neighbors are empty, we either plant all the flowers or finish checking all the plots. So if both neighbors are empty or the plot is at the boundary, we plant a tree by replacing 0 with 1 and decrement the number of flowers. The loop continues until we either plant all flowers or finish checking all the plots. So the time complexity here, as we discussed earlier, is O of n, where the n is the number of plots in the flower bed array. So while the brute force works fine, we can optimize this further by noticing that we can skip some unnecessary checks. So once we plant a flower, the next plot is guaranteed to be a non-plantable due to the adjacency rule. So we can jump ahead in the array. So as we have observed in this case, after planting a flower at this particular index 2, we can neglect this particular check as the flower is already being placed at index 2. So we can directly skip to the next spot without checking this particular index. So this can be improvised by moving the index one step ahead after placing a flower at a particular index. So we can improvise this particular code including a simple step which is I plus plus if a particular flower is being placed at a spot. So in this way, after planting a flower, we skip the next plot because we know it can't be used. So this reduces unnecessary checks, and in the worst case scenario, we are still looking at every plot, but fewer operations are needed. So here the time complexity remains same, but we save time by skipping unnecessary checks whenever we plant a flower. So in summary, we explored both the brute force and optimized solution for the can place flowers problem. So the optimized solution is more efficient by skipping redundant checks, making it faster in practice. So if you found this explanation helpful, make sure to like the video and subscribe to the channel for more daily LeetCode 75 challenge problem videos. Also let me know in the comments if you have any questions or suggestions. Thanks for watching. I'll see you in the next one.